Power to the truth. This is Margo. This is Sunday, September 9th, 2018. And today's title is called Meet the Larsens. And this is a story about a family of ice shelves in the South Pole. They used to be a happy family, but they started breaking apart and becoming dysfunctional in 1995 when Larsen A ice shelf disintegrated, and then in 2002 Larsen B ice shelf disintegrated, and now starting in 2017 and now it's 2018, the Larsen C ice shelf is coming apart. And so I'm going to give you a little history on the Larsens. We're going to get to know them as we're leaving the winter melt season for the Arctic, and we're going to be focusing more attention on the Antarctic as we're heading into the spring and summer for the Antarctic. And we're going to understand the breakup of these ice shelves from abrupt climate change and what the impacts are and why we need to pay attention to these things, and that it's happening faster and faster. And these ice shelves are important because they have been holding back the glaciers, and as the ice shelves go, then the glaciers are flowing more rapidly into the ocean, and thus causing more sea level rise. So what we're looking at here is NASA Worldview from today, September 9th, 2018. This is looking down on the South Pole. We don't have a complete image because the sun is not completely up, but we do have enough to see what's going on with our Larsen family. This is Antarctica, and this is the archipelago on the west side, or the peninsula on the west side of the Antarctic. And as we zoom in, here's the tail of the peninsula, and Larsen A ice shelves used to be along here. This is what is left of the Larsen B ice shelf, and we're going to show that disintegration today too. This is actually considered the remnant down here, this little part. And then down here, the largest part is the Larsen C ice shelf. Now we're looking through some clouds here, but in July of 2017 there was a large part that broke off of the Larsen C ice shelf, and this is it right here. And it has become dislodged this year, and during its winter time has left the side of the ice sheet and has come up, and this is the iceberg here, and it's called A68. And we can see that it's quite large. It is disengaged from the ice shelf, and there is some ice in the north holding it, but that's not very thick, and it's probably going to be melting quite quickly. So no one knows exactly what's going to happen with this iceberg, so we're going to be watching that closely. And then down here, this line is depicting the Larsen D ice shelf, and then there are some other ice shelves on the other side that we really won't go into at this point. But this view here, now these are, it looks like shadows from the clouds here coming down onto the ice shelf. And even yesterday we got a fairly good view of this ice shelf, or the iceberg, and you can see the amount of open water around it on this side on the right, and a lot of open water over here on the left. So we're going to be watching this very closely. So we're just going to, I'm going to go backwards, and we're going to start with the Larsen C ice shelf. And this is the most recent that we have. This is from Gizmodo, and this article was published on September the 4th. And it shows how this iceberg has moved around since July of this year. It broke off in July of 2017, but actually kind of stayed in place until this summer, or the winter for them. And I'll just read this. Since it snapped off the Larsen C ice shelf in July 2017, the trillion-ton iceberg known as A68 has spent most of its time stuck in the mud. Now new satellite data reveals that the berg made its biggest move yet over the austral winter, a dramatic counterclockwise rotation that shows no signs of stopping. About a quarter the size of Wales, or half the size of Jamaica, A68 is the 6th largest iceberg on record, according to the UK-based Antarctic research group Project Midas. Its break from the Larsen C ice shelf following months of build-up captivated the world last year, but since then our attention has drifted elsewhere as the iceberg idled around aimlessly, repeatedly becoming pinned to the seabed or grounded in a shallow area known as the Baden Ice Rise. But in July, under the cloak of darkness that is the Antarctic winter, A68 began to swing northward. Polar oceanographer Mark Brandon recently spotted the action using brightness temperature data collected by the Suomi NPP satellite. This data produces false color images where warmer areas, such as ocean water, shine more brightly than color regions such as ice-covered surfaces. The images clearly show A68 making a big counterclockwise swing starting in early July. By the end of August, the berg had rotated itself about 90 degrees, becoming nearly perpendicular with the shelf. NASA glaciologist Christopher Schumann told us he estimates that A68 has rotated 10 degrees in the past 2 weeks alone, with almost 30 degrees of rotation in the 2 weeks prior. What set A68 in motion? Nobody's sure. One of the problems we have here is that the seabed in this area is fairly poorly mapped. This is from Martin O'Leary. It's usually clogged with sea ice, which makes it tough to get boats in there. Indeed, thick sea ice foiled a British Antarctic survey-led attempt to reach the giant iceberg and study that seabed back in March. Still, O'Leary says the iceberg's recent rotation probably indicates that it's come loose from whatever it had been pinned against for the past year. It may have been shaken loose by winds or ocean currents, or it might be that the natural thinning process from both melting and the flow of the ice has lifted the bottom of the iceberg off the seabed. In any case, it looks like the berg is now a lot more free to move about, so that it will probably continue to rotate and move out to sea. Brandon suspects that A68 will continue on its present course, eventually colliding with the Larsen C shelf. It has a spectacular amount of momentum, and it's not going to be stopped easily, he wrote in a blog post. While O'Leary says a collision is certainly possible, he doubts it would have much of an effect on either berg or shelf, given the slow motion speed at which it would occur. Eventually, O'Leary says the prevailing ocean currents will push the iceberg northwards and eastwards into the Southern Ocean, where it will probably break up and melt. We'll have to wait and see what's in store next for A68, but it seems that this iceberg hasn't finished making a spectacle of itself. And then this is Mark Brandon's blog site. It's called malamoroking.org, and I'll leave links to all of these websites below. And this has been in the news recently. It says a trillion tons of ice on the move, iceberg A68A, and this is from August 31st of this year by Mark Brandon. And he says, just over a year ago, in July 2017, iceberg A68 calved from the Larsen Ice Shelf. I appeared on BBC News before it actually calved, explaining what was happening. And if you click there, it takes you to the link to that short YouTube clip. At first, A68 was slow to move, and as I predicted back then, it likely got stuck on the seabed, we say grounded. It has stayed pretty much in the same place through to July 2018, but now A68 has started to swing northwards. As the light is coming back to Antarctica, at high latitudes, visual imagery is very washed out. But we look at other data such as the brightness temperature, you can see some striking features. And this image is from August the 20th of this year. And you can see that here's the iceberg here. And there are cracks, and here's the peninsula, and here's the Larsen Sea. And then we have exactly the same thing over here, except this is from September the 8th, and we can actually go back in these images. We don't always have something visible, just depending on the satellite view. And it's cloud covered a lot of the time down there. But here we can see, this is from September the 1st. We can see it's hard, there's a big breakaway there, but it has already rotated around. Here it is. But this is down here, what you're seeing is where it had frozen back, but it's already come away from the ice shelf. So this is sea ice, that's not actually part of the ice shelf. But if we go back to August 31st, here's the iceberg. You can see it outlined here. And we'll go back to his article, and he's showing it here. That's A68. And so there it is there. And you can actually see the movement of it. Here it was tilted a little bit more to the right from what you can see of it. And here it is. This is a pretty good outline of it. Remember, you're having to look through some cloud cover on this stuff, so that's as close. Well, we don't want to get too close because then we can't see the image. But if we go back to today, we can see that it's still tilting. It's on the move. You can see it actually tilting up on this right end. There's the 31st. Here we're in clouds. And this is a good view from the 4th. You can see how much it's already tilted up. And so it looks like that top part is kind of swinging around. And here it is from yesterday. And there it is from today. So it's tilted even more. And I have the navy image. Where is it? Here it is. And we can see the thickness of the sea ice. It's about 2 to 2.5 meters on some of this sea ice, but it's quite broken up in some of these areas. But then further out away from that edge, we can see that it's not very thick. It's about 1 meter. And from what I read, in the Antarctic winter, the sea ice is supposed to get several meters deep, or thick, and it doesn't look like it got several meters thick to me this year. And they're at the end of their winter and starting into their spring. So we can see this is the 30-day animation on the sea ice. And so it's pretty much just kind of been in a holding pattern, it looks like, and then going into a forecast period for 7 days ahead of time. But it's kind of been in a holding pattern for the last 30 days. And we can also look at the drift and see how the water has been moving underneath this ice, and so it's been doing kind of a tug of war, it looks like, with that iceberg. And we can look at the GIF here. It's kind of fast. But the currents are moving that iceberg around. And so forth. So we're going to get back to Mark's picture here. With the brightness temperature data set, brighter colors indicate higher temperatures. The Larsen Ice Shelf and A68A are glacial ice, and so cold they appear dark purple. The sea ice is thinner and warmer, and in contact with the ocean, so the purple shade is lighter. The leads, which are cracks in the sea ice, and so open water and or very thin sea ice appear as relatively bright lines. On the bottom right of that image, you can see that under certain circumstances, the brightness temperature data set can see through clouds. And we saw that where we could see through the clouds. We saw that on NASA Worldview. Now you understand what you're looking at, and here are all the brightness temperature ranges from May 1st of 2018 to August 26, 2018, in which I could clearly identify iceberg A68A. The date is in the top right hand corner. So he starts with May 1st. So we're going to watch this movie. And here's the iceberg, and you can see it moving up, moving up. So let's play that again. See, it's down here to start out with, and then it's on the move. Let's play it again. I just find this fascinating to see how this iceberg was on the move during the winter time and while it was so cold. And so what this is showing me, and I'll continue with the article, but it's showing me that it's melting from underneath, just like what we're seeing in the Arctic. It's also melting from underneath in the Antarctic because of the mixing of the warmer temperature of the water and changing salinities and things. You can see at between 7 to 12 July, the weather conditions and ocean currents conspire to swing the trillion tons of the giant iceberg A68 in an anti-clockwise direction. Sentinel-1 SAR satellite imagery from August 29th shows that to the north of the iceberg, the wind is pushing the sea ice northwards faster than the iceberg is rotating. So that's that open water that we saw. And that's the young ice. And so that's a lot thinner. And this is the new growth. And here's the compressed sea ice, and here's your iceberg A68. This has created an area of open water where there is intense sea ice generation happening right now. In the high-resolution imagery, you can clearly see large fragile ice slicks developing in this open water region. My guess is that A68A will continue rotating as it is now around that western point until what is currently the northern edge collides with the Larsen Sea ice front. It has a spectacular amount of momentum, and it's not going to be stopped easily. I should think we will see some interesting collisions with the ice shelf in the next few months. What happened in July 28, 2018 to start the drift? This should be another blog post. Larsen C has an automatic weather station operated by the Utrecht University Institute for Marine and Atmospheric Research. This is the data for 2018. The horizontal axis shows day of year. So it looks like there was a lot of activity with the air pressure there. Just before A68A starts to rotate, the wind speed drops to what appears to be the calmest period of 2018 up until then. Air temperatures fell below -40 degrees Celsius, their lowest values of the year, before a few days later rising above 0 degrees Celsius. The air pressure sensor clearly reads bad data as that was happening. I know this doesn't tell us anything about the data, but it indicates the period was unusual compared with the rest of the year. Basically, something odd was happening. I've looked at the weather maps, but I'm no meteorologist. I will come back to that data in the future. What I do know is it takes a lot of energy to get 1 trillion tons of ice moving. Once it was in motion, a reanalysis data product from the University of Maine shows on July 20th, and it looks like he got this from Climate Reanalyzer, and we can see that we know what this is. This is the 2-meter temperature anomaly map from Climate Reanalyzer on Friday, July 20th, and we can see that the temperatures were quite warm over the whole Larsen area. And so he says it was almost 20 degrees C warmer than the mean over the Weddell Sea and Larsen Ice Shelf. And this is what we see in the weather data from AWS 14 above. At the same time, London, UK was coping a very significant heat wave. This area had some extreme temperatures. There's actually an emperor penguin colony in that region. I wonder how this affected them. I'm going to continue to track A68A. So There's that. So he tracks this stuff and he doesn't know, why this iceberg started moving, but something started the movement of the ocean, got this iceberg dislodged from wherever it had been for a whole year. It had cracked off, but it had been sitting there for a whole year, and then it starts trucking along and it's still on the move. It's still moving. So there's that. I'm going to pause this. Now we're going to go over to Wikipedia, and we're going to give a little bit of background on the Larsen Ice Shelves, why these are important, and how long they've been around. And I'm going to talk about the disintegration of the Larsen B ice shelf that happened basically in about a 3-week period in 2002. And if you think back in 2002, that's when we had such a large extent loss of the Arctic sea ice up in the north in 2002. So I'm thinking 2002 was an unusual year, and it affected the weather all the way around the planet, not just in the Arctic, but also in the Antarctic. And so, these are connected. All of this stuff is connected. So this is from Wikipedia. The Larsen Ice Shelf is a long ice shelf in the northwest part of the Weddell Sea, extending along the east coast of the Antarctic Peninsula from Cape Longing to Smith Peninsula. So here's a picture of it. We can blow this up. So it goes from this tippy point all the way down here. Larsen A is up here. Here's Larsen B. Larsen C is this area. And Larsen D is a long area, but it's not very thick. It's right along the coast there. And there are some more ice shelves over here on the west side. There's Wilkins, Bach, and Strange over here. But this is that peninsula on that west side of the Antarctic. And then the Weddell Sea is over here. It covered approximately 78,500 square kilometers of the Earth's sea with exceptionally thick ice. It is named for Captain Carl Anton Larsen, the master of the Norwegian whaling vessel Jason, who sailed along the ice front as far as 68 degrees south during December 1893. In finer detail, the Larsen Ice Shelf is a series of shelves that occupy or occupied distinct embayments along the coast. From north to south, the segments are called Larsen A, the smallest, Larsen B, and Larsen C, the largest, by researchers who work in the area. Further south, Larsen D, and the much smaller Larsen E, F, and G are also named. The breakup of the ice shelf since the mid-1990s has been widely reported, with the collapse of Larsen B in 2002 being particularly dramatic. A large section of the Larsen C shelf broke away in July 2017. And so here's a map of the Antarctic. And so here's the Weddell Sea, and it's this area along here. That's the area we're looking at today. And this is a really good picture of the ice shelf processes. And we can see that here's the slope, here's the grounding line, here's the ground comes up, and then the ice shelf and the ice stream, this is from the glacier, comes down, then the ice sheet builds up from snow and stuff, and then the shelf extends over the ocean, and then the water from the deep sea comes in under that ice shelf, and so it interacts with the ice shelf and causes things to happen. This is the calving line. That's where you're going to have breaking off of the ice shelf. So you're going to have heat from above, and now we've got heat from below because the water coming in underneath is warmer than it should be. So it's a whole combo plate. The collapse of Larsen B has revealed a thriving chemotrophic ecosystem 800 meters or half a mile below the sea. The discovery was accidental. U.S. Antarctic program scientists were in the northwestern Weddell Sea investigating the sediment record in a deep glacial trough of roughly 1 million square kilometers, twice the size of Texas or France. Methane and hydrogen sulfide associated with cold seeps is suspected as the source of the chemical energy powering the ecosystem. The area had been protected by the overlying ice shelf from debris and sediment, which was seen to be building up on the white microbial mats after the breakup of the ice shelf. Clams were observed clustered about the vents. The former Larsen A region was the farthest north and was just outside the Antarctic Circle, had previously broken up in the middle of the present interglacial and reformed only about 4,000 years ago. The former Larsen B, by contrast, had been stable for at least 10,000 years. The ice of the shelf is renewed on a much shorter time scale, and the maximal ice age on the current shelf dates from only 200 years ago. The speed of Crane Glacier increased threefold after the collapse of the Larsen B, likely due to the removal of a buttressing effect of the ice shelf. Data collected in 2007 by an international team of investigators through satellite-based radar measurements suggests that the overall ice sheet mass balance in Antarctica is increasingly negative. Breakup. This is a picture of the Larsen B ice shelf just kind of disintegrating into the ocean there. The Larsen disintegration events were unusual by past standards. Typically, ice shelves lose mass by iceberg calving and by melting at their upper and lower surfaces. The disintegration events were linked by the Independent newspaper in 2005 to ongoing climate warming in the Antarctic Peninsula, about 0.5 degrees Celsius or 0.9 degrees Fahrenheit per decade since the late 1940s. According to a paper published in Journal of Climate in 2006, the peninsula at Faraday Station warmed by 2.94 degrees Celsius or 5.3 degrees Fahrenheit from 1951 to 2004, much faster than Antarctica as a whole and faster than the global trend. This localized warming is caused by anthropogenic global warming through a strengthening of the winds circling the Antarctic. Another reason these winds are strengthening is because that ozone hole is much thinner, and I can show you that, but that's going to be on the climate update, not today. The Larsen A ice shelf disintegrated in January 1995, and I can't really find that much on that. NASA Worldview doesn't go back past the year 2000. Okay, and then the Larsen B from January 31st, 2002 to March 2002, the Larsen B sector partially collapsed and parts broke up. 3,250 square kilometers, or 1,250 square miles of ice, 220 meters thick, or 720 feet thick, an area comparable to the U.S. state of Rhode Island. And it's still disintegrating. And this Larsen B was stable for at least 10,000 years. So for 10,000 years, this Larsen B was stable, and then in basically a 3-week period or a month period, it disintegrated. And it says in 2015, a study concluded that the remaining Larsen B ice shelf will disintegrate by 2020 based on observations of faster flow and rapid thinning of glaciers in the area. So, we're going to look at Larsen B. This is quite interesting. This is from NASA. Here is the Larsen B ice shelf. And this is starting from January 31st. And it's just a time lapse, and you can see it breaking up, and now watch it just like flowing into the ocean. Isn't that something? And it replays again. And I actually have it pulled up on NASA Worldview, and we can look at it as well. And you have to go through and get days where there's not a bunch of cloud cover for you to see that. So by March 17th and April 13th, it was done. And so here's another website. NASA study shows Antarctica's Larsen B ice shelf nearing its final act. And here's another video. The final act. I don't want to get a YouTube strike. And here it goes. Look at that. And there's the remnants of it. So this is what's happening, and we're in the throes of it. So we're losing the Larsens. Used to be a happy family of ice shelves. Soon to be gone. So, let's look over here. I have January 30th, 2002 pulled up on NASA Worldview. And we can see a lot of open water here. This is Larsen A up here. What was left of it. This is Larsen B. And this is Larsen C down here. So I'm just going to zoom in a little bit. And you can see it's already starting to break off. And you can also see here how it's losing integrity. And the melt has already started here. It's already losing its integrity. And then I'm just going to click forward. And you're going to be able to see this disintegration. That's clouds there. And then you can start to see it breaking up. I'm going to go back a little bit. Out a little bit. There's clouds. And there's some missing data for about a week in here, and it really gets torn up during that week. So I'm wondering what happened again is the case of missing data. We're going to see it. It's from March the 20th through the 28th. Again, this is cloud cover. Okay, now we can see a big piece that broke off here. That's on February the 12th. And if we zoom in, you can see that's a definite piece that's broken off of that Larsen B. Clouds. More clouds. But you can see lots of clouds. Here's the 17th. Look at this. Okay, this is cloud covered. But we can see through the clouds all of that broken up ice and see how it's just coming apart. And look at these big icebergs here. And you know, that's a lot of open water. Of course, this is in the middle of their summer. I don't know if this is traditional for the ice to all melt away. I think it is, but it's not traditional for that ice shelf to just disintegrate like it is. Look at that. You can really see it breaking up there. Of course, we're looking through clouds again. And here is starting to flow down. That's February 20th. Look at this. Here's February 23rd. And it's really breaking up here. Masses of it. It almost looks like there was an explosion of some kind. You know, maybe a volcano went off underneath. They did find a whole bunch of volcanoes under the Antarctic, and some of them are active, and you're thinking that's causing the glaciers to be melting. That's one of the reasons it could be. Okay, we're looking through clouds here, but we can see a massive part of this ice shelf coming off here. Lots of clouds. Okay, this looks pretty. This is March 5th, and now we can really see the migration of the ice starting on March 5th. You can see this is a whole solid migration of that ice sheet just pouring into the ocean. That's amazing to me. That's just amazing. Let's see what kind of cloud cover we have. There's no cloud cover there. So we're actually seeing the sea ice. And it's pouring. It's flowing. The ice is flowing into the sea from that ice shelf. It's on the move. Now there's a bunch of cloud cover, but you can still see through and see the edge of that ice. And it's flowing over here too. Here's March 7th. This is another really good view with no clouds to speak of. Let's make sure. Yep, that's cloud free. This is all Larsen B flowing. And look at these chunks that are broken off and how it's just splintering on the edges. Cloud cover, clouds. That's the thing. It's so hard to get days when it's cloud free to really see what's going on. Okay, here's March 14th. Now we're looking through clouds, but we can see the edge. It's still pouring into the sea, into the ocean. More clouds, more clouds. Okay, this is a good view. It's still on the move. March 17th, look at that. There's clouds there. And see that cloud filter didn't work. Sometimes it doesn't work. Now we're not up to the missing data yet. We're almost there. But we can still see it pouring out, and it's even spreading out down here as it's going into the ocean. Let's get a close up. Here, that's as close as I can get in. Okay. Here's the 18th. You can still see it, and now there's chunks breaking off down here. Here's the 19th. And here's our blackout period. Does this look familiar? Blackout. This is all blacked out for 8 days, 9 days. March 20th through the 28th. I just wonder what happened during those 9 days. I really wonder. Here's the 29th, and it's all cloud covered. And it's not just cloud covered, but notice the ripples in those clouds. Those are some very strange, almost like harmonics in the clouds. Very strange to me. Here's March 30th. It's still cloud covered, but we can see through the clouds and see the ice is still on the move. And it looks like the ice has spread out down here and is dispersing into the ocean. It's the 31st, totally cloud covered. Here's April 2nd, mainly cloud covered. April 4th, 5th, 6th, and we can see the ice is coming out way down here now. Still on the move. Now this is a pretty good image. Even though it's cloud covered, there's a lot of it that's not cloud covered, and we can see through the clouds on these edges. So we can see that it's still flowing. There's the edge into the sea. The ice is still dispersing. It's just, I'd love to see that missing data. I'd love to see those days and without clouds. Here's April 8th. 9th, 10th, 11th. This is a pretty good view. We can see the ice is really starting to disperse out. 12th. You can see how it's flowed out. 13th. That's a pretty good view. Look how far out it's flowing now. That just blows my mind. It just... Here's the 19th of April, and we can still see it's flowing out to the sea. This is the remnant of Larsen B, that little area there, they have that marked off. So many clouds, you just can't see it. It's hard to see. Here's May 1st. Now we're starting to lose data because they're heading into their fall and winter down there in the first part of May. Let's see what we can see. Here's May 7th. And that's it. We just don't have any more data. So that's what happened to Larsen B. And so then here we are. So this is what's left of Larsen B. This is not the ice sheet, it's just a remnant. So, but it's still dispersing, and see how that ice has broken away already, and this is just the beginning of their melt season. This is just the beginning. So this is the story of the Larsens, the disintegration of the happy ice shelf family, brought about by abrupt climate change. We're in a new season. Many changes are upon us. Who knows what lies ahead? Time is short. Time to get your spiritual houses in order if you have not done so. I love you guys. Until next time, God bless. Take care. Goodbye.